Okay, let's look at some new applications of linear systems. Linear systems have several real-world applications. We've already seen the cost, revenue, profit ones, supply and demand, and break-even analysis applications. So now we're going to just look at some more general applications. So this first question says that the total number of passengers riding a city bus during the morning shift is 1,000. If a child's fare is 50 cents and an adult fare is $1.50, and the total revenue from the morning fares is $1,300, how many children and adults rode the bus? So we definitely have two different variables that we're trying to find, children and adults. And we have two different equations that we can write because we have just the amount of children and adults, and then we have also the money from the children and the adults. So those are going to be our two equations. I like to just use variables that have meaning in my equations. So instead of turning everything into an x and a y, in this case, I'm going to use a C and an A for child and adult. That way, when I get completely finished, I know what I've found and I don't have to try to decide which number goes where. So my first equation is going to be that C plus A equals 1,000 because there were 1,000 total children and adults. And then the other equation is the money, so that 50 cents per child plus $1.50 per adult brought in $1,300 in fares. And now we want to solve this. I think this one's set up pretty good for either substitution or elimination. You could simply take that top equation and either subtract the A over to solve for C or subtract the C over to solve for A. But I really like to do the elimination method. So I'm going to just multiply this top equation by negative 0.50 to create opposite C's. So that'll give me negative 0.50C minus 0.50A equals negative 500. The second equation stays exactly the same. I don't need to multiply it by anything. My C's are now opposites, so they will cancel. I get that 1A equals 800, and that's already solved then. So A is 800. So I know that there were 800 adults, and then I can go back and just sub that into the easier equation I'm going to choose. I'm going to choose this equation to sub it back into. If A is 800, then what is C? C must be 200. 200. And then if you want to check that, if you're not completely sure, I mean, it makes sense that 800 plus 200 is 1,000. If you want to check it really quick, you could, this is optional, it's supposed to work in both equations. So we could make sure really quick that it actually works here as well. And if you check that, it's going to, you're going to get 100 plus 1,200 equals 1,300. So this checks. So A, 800 adults, C, 200 children. We've solved that application problem. A lot of what I find is that the difficulty comes in the setting up of the equations, and then the solving is almost the easier part. So on this one, we're just going to practice setting it up, and then I will leave it to you to solve if you prefer, if you feel like you need the practice. So in this case, it says a dog food manufacturer makes two types of food, Sparky's Special and Fido's Favorite. Each type uses two types of meat, chicken and beef. Each bag of Sparky's Special has 4 units of chicken and 3 units of beef. Each bag of Fido's Favorite has 7 units of chicken and 5 units of beef. On one day last month, the manufacturer had 127 units of chicken and 93 units of beef available. How many bags of each type of food could be made? Okay, so we want to practice setting this up only. If you have trouble setting them up, something that I would recommend is making a chart. So I've made a chart here with the ingredients, chicken and beef on the side, and the different foods, Sparky and Fido, on the top. And I've given them variables. So I've given Sparky's X and Fido Y. I didn't want to use an S here because S's look like 5s. So I went ahead and stuck with X and Y. And if you format things in a chart like this, it can make it a little bit easier to keep track of. So it looks like, if I go back to my wording up here, each bag of Sparky's has 4 units of chicken and 3 units of beef. So if I go to Sparky's and then go down, chicken is 4, beef is 3, and I see that both of those need an X with them because they're in the X column. And then I can see if I move on to Fido's Favorite, has 7 units of chicken and 5 units of beef. So I can put a 7 with the chicken and a 5 with the beef and see that those need Y's with them. And then we also have our totals then at that point. So the totals are 127 with the chicken and 93 with the beef. And by formatting it that way, I've now created my equations. I can just grab the information out of that chart. So it looks like my equations are going to come from doing this. 4x plus 7y equals 127. That's how much chicken is needed to do this. And 3x plus 5y equals 93 would be the beef. And again, at this point, you could now, I would probably solve this one by elimination as well. And I'm going to give you the final answer to this, and then this one can be left up to you to try. If you feel like it, if you feel comfortable doing these at this point, then you could skip this part. So it should end up being 16 bags of Sparkies and 9 bags of Fido.